So hello guys, in this video we are going to discuss about the rational numbers, that means the real numbers and their decimal expansion. So basically real numbers I can categorize into two, that is the rational numbers and the irrational numbers. Okay, rational numbers as well as the irrational numbers, in which I'll start with the rational numbers. So basically rational numbers, we have different types of decimal expansion. There are two most important decimal expansion, that is one is terminating and another one is non-terminating repeating, or we can say recurring. So non-terminating, recurring, or we can say in other words repeating. Okay, so we'll understand what all things is there in this. So there are two under the rational numbers. So basically rational numbers expansions are two types, one is terminating, other one is non-terminating. Let us take one example. Suppose if I divide, or if I do 10 by 3, that means what? 3 outside, 10 inside. That means what you have to do? 3. So I'll just write it as 3 3s are 9, then again divide, 1 is the remainder, again put one point over here, it becomes 10. So again you have to do 3, so I'll get again 9, correct? Again 1, again 3, again 0, again 9, like that it goes on. So basically what is the meaning of this then? So you can see that the quotient will go on repeating. And the terminating, what is the meaning of terminating and non-terminating? Terminating means the remainder becomes 0. Here the remainder is not becoming 0, that means it is not terminating. It is non-terminating. Whenever the remainder becomes 0, it is terminating. If it is not 0, then it is not terminating. Now what is the repeating? Repeating means the quotient, you can see, observe this, it is 3 digit is repeating, correct? So I can categorize in this form 10 by 3, or I can say one more examples as 1 by 7. These are all decimal expansion which comes in the category of non-terminating repeating, because because the remainder is not becoming 0. You can observe in this division. And the repeating means the quotient, you can see quotient here, it is 3.333. it goes on till the end, we can say it goes on to the end. Further you can do the division, again you will get 3333. So I can write it as 3.3 bar. What does it mean, bar? Bar means basically it denotes that this digit is repeating infinite times, we can say, okay, forever. So basically, so non-terminating repeating categories, I can categorize this examples I can give. Now let us see one more example based on the terminating thing. These are all rational numbers and their decimal expansion. Okay, now for example, for the terminating, 7 by 8, this is also a rational number. So let us take, so 8 outside and 7 inside. Now you have to divide, it becomes 0 point. This becomes what? I'll put one 0 here, 70. So 8 8s are 64, subtract, you will get 6. Again I'll put one 0 here, 8 7s are 56. Again 4, so 4, I'll put one 0. 8 5s are 40. So I am getting remainder as 0. Now you observe here, I am getting remainder as 0. That means it is terminating, and you can observe that the quotient is not repeating, it has stopped there. 875, it is not repeating also, anyways it has stopped here. So 0.875 will be the decimal expansion of this 7 by 8. So I can say that 7 by 8 comes under the category of what? Terminating. You can see the examples. So basically for the rational numbers, there are two decimal expansion, one is terminating, another one is non-terminating repeating. So I'll repeat. So basically terminating means the remainder becomes 0, non-terminating means the remainder will not become 0, and repeating means the quotient repeats. any of the digits will repeat. Okay, so let us talk about the decimal expansion of the irrational number. So irrational number means which cannot be written in the form p by q. So we have the example as root 2, and we can take one more example 5. So for the decimal expansion of root 2, we know that it is denoted by around 1.4121356, like so say. Now for the pi, we know it is 3.141592, and so on. Some more values are there. So basically here you can understand that root 2, it is 1.41 decimal expansion of root 2 is given as this. Now here the numbers are not repeating, and we can say it is the irrational number decimal expansion will be under the third category, that is non-terminating nor non-terminating non-repeating. Okay, so basically non-terminating and non-repeating, so it is under the third category. So basically I'll give you the last statement, that it is basically we have two conditions. So here is the first condition, that is the decimal expansion of rational number is either terminating or not terminating recurring. Recurring means repeating only. Okay, so let us understand this. The decimal expansion of rational number is either terminating or not terminating recurring. As I said already, that we have two decimal expansion of a rational number, that is terminating as well as non-terminating and repeating. Now, in other words, we can say a number whose decimal expansion is terminating or non-terminating repeating is a rational number. So the number whose decimal expansion is terminating or non-terminating repeating, the other wrong way. So it's basically vice versa. Okay. Now we have the second condition, that is the decimal expansion of an irrational number is non-terminating, non-repeating or non-recurring is basically what? So decimal expansion of irrational number, we have discussed about the rational number, now it's irrational number. So it's basically we have discussed that it is non-terminating as well as non-repeating. In other words, we can say a number whose decimal expansion is non-terminating, non-repeating is irrational. Okay, so it's basically the vice versa. So we have two conditions about the rational number as well as for the irrational number.